So now let's see how we can add a test to the invoice using the Mikado method. Um, the Mikado method is a technique mostly for refactoring, but it can be used for almost any kind of changes. Um, to split large changes in small independent steps that we can do one after the other, and that every step can be committed, integrated, and deployed alongside other developments, maybe over a period of days, weeks, or even months, or maybe even longer. That would be extraordinary, but it's technically possible. So it's called method because it's a bit like an algorithm. So if we look at it here, how it goes. So the thing is that first you'll try to do your change in a very direct and straightforward way. You'll see, you'll check for regressions. So usually you'll use your compiler, you'll use your tests, you might use even manual testing to see how things are going. Um, at this point, you might try a bit of scratch refactoring. So this is trying trivial fixes and to see if you're able to fix the thing very simply for two reasons. The first is that if ever the non-regression passes, so the non-regression here, I'm talking about compilation, your unit test, your tests, your whatever things you have at your disposal, then you can commit because it means that the change you wanted to do is done. And if ever that was really your end goal in all the big project you had, that's fine, you're done. Otherwise, we're going to go into recursion. So to do this, we're going to draw a graph to show all the prerequisites you have for your change. So when you did your scratch refactoring, your trivial changes, you certainly understood and learned better what you needed to do before. And so this is what you're going to capture in your graph. And at that point, you can revert. So revert from Git. You'll get back to your working state, the state you had before, but all the knowledge you gained from trying this will be stored in your graph, which means that you now save to recurse on the prerequisites. And now let's see how to do this. So in this test, here it is. What we'd like to do is the same thing as before, instantiate the invoice, add purchase novel, and then test the total amount. So what we're going to do is that we're going to start to draw a graph. So for this, we've got a Miro again. So we've got a Miro. Here it is. So I'm going to write this. So test. We're going to write this test, and I'm going to call it applies tax rules when computing total amount. So any Miro, here I'm using Miro, but any mind map or even a simple sheet of paper will do. It's just that in remote setting, it's easier to share with your colleagues if you're using an online tool, and mind maps are great for that. So let's see what we are. So fortunately, we already have the first steps. So we'll just be using these first steps as prerequisites. We already know that. So let's first add one test here, one prerequisite here, instantiate an invoice sent to USA, then add a purchase novel costing 50 to it, and finally assert the total amount. Here we are. So we've got these three steps. We see directly, it's very straightforward to see that there are dependencies between these steps. And we see, for example, that we need to do this before we can do that, and we need to do this at the end. Maybe we could even do this one once we have that. It depends, but for the test to pass, we'll need that. So let's start. So now that we've captured all this, we can just remove this. It's not necessary anymore. And what we can do now, if we look at the algorithm here, we just extended the graph of prerequisites. There's nothing to revert, and so let's recurse on a prerequisite. So instantiate an invoice sent to USA. Let's try this. So invoice equals new invoice, and what shall I put here? So a name, client name, Joe. That's easy. And then a country. Oh, a country. So USA. So now I see here that USA doesn't exist. It's not there yet. So I'll have to instantiate it. So I could do it right now, but really for the sake of the demo on the Mikado method, what I'll do is I'll capture this as sorry, I'm having Miro issues. Here we go. Instantiate USA country. Here we are. So I've captured. If we're here, I've extended graph root. So next step is to revert. So I'll undo this, I'll undo that, that. Here we go. Which means that I can now work on the prerequisites and instantiate a USA country. So the nice thing, by the way, is that here I'm still in a green state, so there's nothing in my test, obviously, but I'm still in a green compiling state. And I can now try to instantiate a country. Country, USA equals new country. So what will I need? I'll need a name, USA. I'll also need a currency, so dollar, it's an enum, language, English. And this is compiling. It's even, the test is passing, even if it's not testing anything for the moment, but at least I could commit it, integrate it, and everything. It wouldn't break the CI. So, which means that if I look back to my graph, I've tried trivial fixes. It's passing, so I should be able to commit. It's not my end goal though, but I should be able to commit. So that's exactly what I'm gonna do. Git status, git add, git commit. I'll add a simple Mikado. So USA country instantiated. And I can mark my step as done in the Mikado, which means that I can now start again. So I've just committed that, and I've got no prerequisites. I can still recurse on the other parts of my graph. So next step here, instantiate an invoice sent to USA. And let's try that. So invoice equals new invoice. What do I need here? I need a name, Joe, and a country. I can use USA directly. And it seems to be building. The test should be green. Great. So, which means that I can commit again. Invoice sent to USA. And I should be able as well to mark this as done, which means that I can now start to recurse on this one. So your job now is to continue that and to build the graph as you go.